All right, so for question number 1, they're asking us about absolute maximums, roots, absolute minimums. So here we don't just want to use the derivative to find where the relative max and min could be, where that horizontal tangent line happens. We also have to check our endpoints because we're looking for absolute. So I think this is the extreme value theorem if you're looking for it in your notes. So that means they asked about roots. Those are x-intercepts, so I'm going to go ahead and find those. I'm taking the original function. I'm going to set it equal to 0, and I need to factor that to solve it. So I have a GCF of x squared, and that leaves me with x minus 3. So my roots are at 0 and 3. And then I also need to find the derivative. So the derivative is 3x squared minus 6x. And I need to set that equal to 0. Technically, you should also see where it's undefined, because that's where your extrema could be. This quadratic is not going to be undefined. So we're just seeing where it equals 0. Factoring out of 3x, and that leaves me with x minus 2. So that gives me x equals 0, x equals 2, and then I also, so I need to check all these points. I can see that this root is also a relative extrema, most likely. So I just need to check all of these, and then I need to check the endpoints. So I'm going to check f of 0, I'm going to check f of 2, I am not going to check 3 because 3 is not in the interval, but then I'm also going to check the endpoints. So -3 and +1, I'm going to check all of those. So to find the coordinates of the point, I should not be plugging these into the derivative, I should be plugging these into the original function. So for the first one, I have 0 cubed minus 3 times 0 squared, which is going to give me 0. Then I have 2 cubed minus 3 times 2 squared. So 2 cubed is 8. That's -3 times 4, so that's minus 12. So that gives me -4. Now I've got -3 cubed minus 3 times -3 squared. And I will tell you honestly, I got this problem wrong because when I did -3 cubed, I forgot that it was still negative. So -3 cubed is -27. And then I've got -3 times +9, which is another -27. And that is -54. And then the last one, we've got 1 cubed minus 3 times 1 squared, which is 1 minus 3, which is -2. So what I did next is I labeled where my maximum and my minimum was. So 0 is my root. I'm going to go ahead and write that that is r. And then I can see that my capital M, my maximum, is at that same point. That's also at 0. And then my minimum is at that -54. That is the absolute lowest y coordinate we can see. Now in the answer choices, they reference endpoints and they reference critical points. So critical points are where the derivative equals 0 or where the derivative is undefined. And so these two right here are our critical points. -3 and 1 were the endpoints. So we are looking for the answer choice that says the root and the absolute max are critical points and the absolute min is an endpoint. And that happens for A. All right, number 2. What's the value of C in the open interval 0, 4 that satisfies the mean value theorem? So mean value theorem, in my notes I wrote that it was the average, which may or may not help you, I'm not sure. But that's kind of like going, I was thinking like average rate of change or average slope. That in my head kind of reminds me that it's dealing with a slope here. So to do that, we plug in the ends. So f of 0 would be the square root of 0 plus 4 which is 2. F of 4 would be 12 plus 4. Square root of 16 is 4. So that gives us the 2 points 0, 2, and 4, 4. So my slope between those two is going to be, need a parenthesis, 4 minus 2 divided by 4 minus 0. So that's 2/4, which is 1/2. So the mean value theorem says that if on the interval, if the average slope of the interval using the endpoints is 1/2, then there is some value on that interval for x, it's a c, we call it c. There's some x value called c where the rate of change at that moment is also the same, is also 1/2. So now we're going to go ahead and take the derivative, because that's where we get that instantaneous slope. So I'm going to think of this as 3x plus 4 to the 1/2. So I bring the 1/2 to the front, 3x plus 4 to the negative 1/2, multiplied by the derivative of the inside, which is 3. So now I know that this somehow is going to equal 1/2. So I'm going to go ahead and rewrite this. 3 on the top, on the bottom 2, and then square root 3x plus 4. That somehow equals 1/2. I'm going to get rid of I'm going to kind of start to get rid of the fractions. I'm just going to go ahead and multiply by 2 and multiply by 2. And I'm doing that because that makes things look a little bit nicer. And then I can go ahead and multiply my square root up to the other side. 1 times the square root just equals that square root. And now I can go ahead and square each side. So 9 equals 3x plus 4. Minus the 4 over, I get 5 equals 3x. So x equals 5/3. I just want to make sure and double check that this c value is on the interval, and 5/3 is between 0 and 4. And so the answer is 5/3. All right, problem 3. So they want to know on which intervals is the function continuous, or it is continuous, on which intervals is the function increasing. They gave us the derivative, and so we just have to remember that to check increasing versus decreasing intervals, we always use where the derivative equals 0, which is when the top equals 0. And so if we take the top and say that it equals 0, that would happen at x equals 0 and x equals -1. It also could be determined by where the derivative is undefined. The undefined portion is where the derivative equals 0 on the bottom, so you're dividing by 0 there. So x minus 1 to the 1/3 equals 0, and that happens at x equals +1. So here I went ahead and drew my number line. And then I thought of numbers to plug in. So over here, if I'm plugging in a -2, -2 squared is positive. -2 plus 1 is negative. -2 minus 1 to the 1/3. 1/3 is a cube root. If you cube root something, the sign stays the same. So a cube root of a positive is positive, cube root of a negative is negative. So the cube root of -3 is still negative. So this is going to be a positive, right, because those cancel. Over here, I'll go ahead and plug in -1/2. So -1/2 squared is positive. -1/2 plus 1 is positive. -1/2 minus 1 is going to be negative. So it's negative. Positive 1/2 squared is positive. 1/2 plus 1 is positive. 1/2 minus 1 is negative, so this is negative right here. If I plug in 2, 2 squared is positive, 2 plus 1 is positive, 2 minus 1 is positive, so that's positive right there. So on which intervals is it increasing? It's increasing right here and right here, so that's -infinity to -1 and 1 to infinity. And so that is B. All right, points of inflection. So I will admit I got this problem wrong. I read it and I was like, no frickin' clue. That's weird notation. I'm uncomfortable with that. And then when I went back and looked at the answer key, I was like, oh my gosh, I totally could have gotten that. So the trick here is to think about what these transformations are saying and how they affect individual points on the graph. So for the first one, if you look at the inside of the function and it says minus a number, that means that you're shifting the function to the right. So that means the points, if you look at the points, you have an x, y as the normal point, and you shift it to the right some, the x coordinate is going to shift to the right, the y coordinate is going to stay exactly the same. And so they're saying the x coordinates are going to shift. They're going to be the x coordinate of the point of inflection plus however much you should shift it to the right. And so 1 is actually true. The next transformation is a multiplier that's in front of the function. That is a vertical stretch. So if your points were originally x, y, and you stretched it by 2, or in this case you stretch it by b, the x coordinate stays the same, but the y coordinate is multiplied by that stretch value. So here they are saying that the x coordinates are being multiplied by the stretch value, which is not true. So this one is false. For the third one, the transformation, you can see a multiplier on the inside of the parentheses. So that's horizontal, stretch or compression. And just like the minus a means right, not left, a multiplier inside means that you are compressing, not stretching. So we are compressing. This is a vertical or a horizontal, excuse me, horizontal compression. That's something that happens to the x coordinate. So if our original was xy, then our new point would be x divided by that number, and then the y would stay the same. And here in this notation, you can see that's what they're doing. They're taking the x coordinate of the point of inflection and dividing it by that number. And so we're going to say that 1 and 3 are the correct answers. I know I missed that one too. All right, here when they say the limit as x goes to infinity, that is the limit at infinity, aka the horizontal asymptote or slant asymptote. So when we look at this, that means that we are looking for the highest exponent of x on the top and the bottom. So the highest exponent of x I can see on the top, the 14, when you plug in infinity, the 14 is not going to affect your problem at all. So at the top, I'm looking at square root of x squared. For the bottom, the 3 is not going to affect me, but the negative 2x will. So I'm looking at my highest exponents of x. Square root of x squared is going to cancel, and you just have x over negative 2x. And if you have infinity plugged in here and here, those are exactly the same size. So the limit is negative 1/2. Next question. All right, this is another one that I got wrong. I got it wrong because of this typo right here. It meant f of x, not f prime of x. So if that affected you, I totally understand. So what I did when I went back and fixed it is I made a list of all these intervals. So I've got negative 3 to negative 2, and negative 2 to negative 1, and negative 1 to 0, and 0 to 1, and 1 to 2, and 2 to 3. Okay. So we want to see where the original function is increasing and concave up. And they gave us a graph of the derivative. So we know that when the derivative is below the x-axis, the original function was decreasing. When it's above the x-axis, the original function was increasing. So I'm going to write just minus for below, plus for above. Okay, so this is below the x-axis, this is above. That meant that the original function was decreasing, increasing, 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 decreasing. Now, the relationship between the derivative and the second derivative is that if the derivative is increasing, then that would mean that the second derivative is going to show up above the x-axis, which means that the original function was concave up. So I'm just writing down from -3 to 2, the derivative is increasing, which means that the second derivative is positive. Increasing, decreasing, increasing, decreasing, decreasing. So the places where the original function are both increasing and are concave up would be these two intervals. And so the answer is D. Number 7 is another question I got wrong because I was rushing, I think, or I was overconfident. I was like, oh, I know how to do this problem, and I made silly mistakes. So make sure you're careful. The fencing goes all through where the black lines are. So that's x, this is x, this is x, this is x, this is y, this is y, this is 2y. That is what I did not do. I did not label the inside ones, I only did the outside ones. And if you do the outside ones only, the answer choice is there. So be careful to not get overconfident, still be thorough with your work and talk yourself through it, because it's unfortunate when you get something wrong that you know how to do. So in the problem they say the perimeter is 100. When we look at the fencing that we have, well, and perimeter is a loose term. That's actually kind of what made me get the problem wrong, is only looking at the outside. It's really the fencing. I guess I could say fencing equals 100. And so my fencing is 1, 2, 3, 4, 5 x's, and 1, 2, 3, 4, 5, 6 y's. And then I know that my area is going to be one side times the other, so that's 2x times 2y. And they're asking me what value of y produces the maximum total fenced area. So I know that when I use this equation, 5x plus 6y equals 100, I want to substitute an x into the equation and get this area equation totally in terms of y. So I'm going to go ahead and say 5x equals negative 6y plus 100. And I'm going to divide by 5. So x is negative 6/5 y plus 20. And then I'm going to go ahead and take that x and plug it in for my area formula. So 2 times negative 6/5 y plus 20 times 2y. So that gives me, I'm doing 4y being multiplied inside these parentheses. So when I multiply 4 over 1 times negative 6 over 5, that gives me negative 24 over 5y squared. And then plus, that's just 80y. Now to maximize or minimize, we have to think about taking the derivative and finding that high point or that low point. So that's where we take the derivative, set it equal to 0, do our number line. So number line if we need to, in these problems we usually didn't. So my derivative is negative 48 over 5 y to the 1 plus 80. And so I'm setting that equal to 0. And that gives me 80 equals, I'll add this over, 48 over 5y. And then I need to solve for y, so I'm going to go ahead and multiply by 5 on each side. So 5 times 8 is 40, so this is going to be 400 equals 48y. And then divide by 48. I did this problem without using a calculator because I can't remember if you can or not. So if you want to look back and see what the directions last said, then you could potentially use a calculator on this. But I just simplified by dividing by 2 repeatedly. So 200 over 24, 100 over 12, 50 over 6, 25 over 3. And that happens to be the answer. Woohoo! Number 8. So how many of the inflection points are also extrema? So they're asking you to work with the first derivative and work with the second derivative and see what the problems have in common. I also got this problem wrong because in all my calculations I had one sign error. I had a positive or I had a negative where I was supposed to have a positive, and it made me get the answer wrong. So again, overconfidence, working too fast. You just got to be careful to be real methodical when you do these. So for this one, the first derivative is 5 times 12 is 60. So 60x to the 4th minus 20x to the 3rd. We're going to set that equal to 0 and solve it. So I have a GCF of 20x to the 3rd, and that gives me 3x minus 1. So x equals 0 and x equals 1/3. So on my number line I've got 0 and 1/3. So if I plug -1 in here, that's going to be negative. If I plug -1 in here, that's -3 minus 1, that's also negative, so this is plus. If I plug in a fraction smaller than 1/3, it's like 1/6. If I plug 1/6 in right here, that's positive. If I plug 1/6 in right here, I get 3/6, which is 1/2. 1/2 minus 1 is negative. So that's negative. And then for this interval, I'll go ahead and use 1. So if I plug 1 in there, I get positive. If I plug 1 in here, I get positive. Okay. Now I got to find my second derivative. So my second derivative is 240 x to the 3rd minus 60 x squared. For me to set that equal to 0 and factor it to solve it, I'm going to see that 60x squared is my GCF. 240 divided by 60 is 4x minus 1. So I have 0 and I have 1/4. Now, they only want to know what we have in common. So that means I only have to figure out if 0 is actually a point of inflection or not. I have to figure out these two signs. I don't have to check this section, which is kind of nice. So I'm going to go ahead and try -1. So -1 squared, that's going to make that a positive. Plug in a negative right here, that's going to make that negative. Yep. So that's a minus. I'll plug in 1/8. That's going to be positive. 4 times 1/8 is 1/2. 1/2 minus 1 is negative. So negative, negative. So 0 is not a point of inflection, but it is an extrema. We don't have any points of inflection and extrema in common. The answer is none. The little mistake that I made is when I plugged in -1, I was writing it down. I wasn't doing it in my head. And I just saw the negative and said that was negative, and I did negative times negative is positive, and I got a plus right there, and I said that my answer was 1. So just be real careful. All right, for this next one, they want us to find the distance between, if an object is moving along two different curves. If they both begin at t equals 0, at what time is the distance between them a minimum? So to find the distance between something, you're actually going to subtract them. So the distance between S1 and S2 is going to be S1 minus S2. And I'll go ahead and put that in order. And so now to see if the distance is a maximum or a minimum or whatever, now we have to take the derivative and then we have to do our number line. So 3t squared minus 2t plus 0. I'm going to set my derivative equal to 0 and factor to solve it. So I have a GCF of t. My leftovers would be 3t minus 2. So that gives me a t value of 0. And a t value of 2/3, and I'll go ahead and make my number line here, so 0 and 2/3. So a number that's smaller than 0 is like -1. So if I put a -1 in for this, that's negative. If I put a -1 in for that, that'd be -3 minus 2, which is also negative. So this is a positive right here. I need to pick a number between 0 and 2/3. I'm going to go ahead and pick 1/3. I plug it in there, I get a positive. 3 times 1/3 is just 1. 1 minus 2 is negative. And then over there, I'll go ahead and pick 1. So that's positive. 3 times 1 is 3. 3 take away 2 is still positive. So if I'm looking for a minimum, the minimum would be found, this is up and comes down, that's a max, down and comes up, this is the minimum. So our minimum is at 2/3, so the answer is C. All right, number 10. So for this one, I was actually able to figure out the answer on this one. I did get this one right on my own. I was able to figure out the answer just by looking at the clues, and I didn't even have to make it all the way through the clues to get the answer. So this first clue right here says that as x goes to -infinity, which is the left, the limit is -1. So what that told me is that it kind of looks like a horizontal asymptote of -1, only on the left side of the graph. It could be the left and the right side, but I'm not sure. But for sure on the left side of the graph is getting closer to -1. So A is a good graph for that, D is not, B is not, E is not, and C is a good graph for that. So I've already narrowed it down to 2. Next, I can see the limit as x approaches 1 from the left, the limit as x approaches 1 from the right. So this to me is looking like we've got a vertical asymptote right there. So this, I'll go ahead and write down, I had a horizontal asymptote. Here I've got a vertical asymptote most likely. So my 2 leftover choices, I can see both of those as having vertical asymptotes. A and C both look like that. But here it says on the left side the graph should be going up. So in A and in C it's doing that. It's going up as it approaches 1. On the right side of 1 the graph should be going down. A is not doing that. C is. So I was like, well, probably C then. That seemed too easy to me, so I continued to look at the other clues just to make sure I was getting it right. So the first derivative is greater than 0 everywhere except x cannot equal 1. So if the first derivative is greater than 0 everywhere, that means that the graph was increasing everywhere for the original function. So when I looked at this, I could see that, like, yep, if I have a little guy who's walking, he's walking kind of up and out of a valley. This guy would be walking up and over a hill. So either way, going up. So increasing. So I was like, okay, that makes sense. Got that. The second one says the second derivative is greater than 0 if x is less than 1. So that's talking about concave up. X is less than 0. That's concave down. So when I compared, I could see, yep, this is concave up, and yep, that's concave down. So all the clues really supported that, and that one was not too bad. All right, number 11, we are back to where we can be using a calculator. Number 11 says that we're working with this function here. The graph has a point of inflection nearest to, I'm not sure where, but they gave us the original function to find a point of inflection. Sorry, they didn't give us the original, they gave us the first derivative. To find a point of inflection, we need the second derivative. So I said my second derivative, I got a product rule here, so I said my first times the derivative of the second minus, no plus, plus the second times the derivative of the first, plus, and then this one over here is a quotient rule, because of course, why not? So we've got low d high minus high d low divided by low squared. And so to be able to find the point of inflection by hand, we would have to set that equal to 0. Heck no, I'm not doing that. So what I went ahead and did is I graphed this on my calculator and I looked for an x-intercept. And when I did that, I found that the answer was B. So I'm not going to do that for you. You should plug it in and make sure that you could get that as well. I set my window pretty small. Your window doesn't have to be super big. You don't have to see the whole curve. You just have to see these x values. So your window can be fairly small because those are pretty small x's. So that's what I did there. All right, questions 12 and 13 refer to this information. So here it says, during what time intervals is the speed increasing? I got this one wrong because I forgot the little trick about speed. So the trick about speed is if the velocity and the acceleration have the same sign, then the speed is increasing. If they have opposite signs, then the speed is decreasing. And if you want to know why, you can go back and read. So we are looking for where their velocity and the acceleration have the same sign. So that means I need my first derivative. So 3t squared minus 14t plus 8. And I need my second derivative, so 6t minus 14. And I need to solve each of those, and I need to draw a number line for each of those. So this one, when I solve, I have to factor. I know I'm going to have a 3t and a t, right? So these other two numbers have to be two numbers that add to 8, or multiply to 8. And I know that we're going to be adding up to some negatives, so to multiply to a positive 8, I'm going to have two negative numbers if I'm adding to some negatives in there. So the numbers are 2 and 4, or they could be 1 and 8, and I'll just go ahead and give you the answer. There's a 4 there and a 2 there. You could do this by kind of guessing and checking, but it would be 3t squared minus 12t minus 2t plus 8. So if you can't remember any of the shortcut tricks for factoring, guess and check will work just fine. So I have a t value of 2/3 and a t value of 4. So I need to draw my number line. 2/3, 4. Over here, set that equal to 0. I'll add the 14 to the other side. I'll divide by 6. And 14 over 6 can be simplified. You can divide the top and the bottom by 2, so that gives me 7/3. All right, so now I need to figure out my signs. So for this one, a number that is smaller than 2/3 would be like 0, for instance. So 3 times 0 is just 0. So 0 minus 2 is negative. 0 minus 4 is also negative, so that's a positive right there. You can plug in 1. 3 times 1 is 3. 3 minus 2 is positive. 1 minus 4 is negative. And then a number bigger than 4, like 5. 3 times 5 is 15, so that's definitely positive. 5 minus 4 is also positive. Okay. And then down here, I need to do the same thing. So plug in a number smaller than 7/3, like 0. 6 times 0 is 0 minus 14, that's negative. A number bigger than 7/3, like 10. 6 times 10 is 60. 60 minus 14 is definitely positive. Okay, so what we're looking for is what interval these would have the same sign on. So I can see that here we've got negatives happening. So that would be kind of like, if we were to think of these kind of combined like this, they're both negative from 2/3 to 7/3. Here we got negative and positive, that's not helping us. But here we've got positive, and that's going to be from 4 till the end of the interval, which was 10. So the answer that had those two intervals was E. All right, now here it says, what is the position of the particle when it is the farthest to the left? So we know it's the farthest to the left when the x value is the most negative, all right, because x is left and right. Now this is kind of an interesting problem because our x-axis is actually representing time, and our y-axis in the problem is kind of acting like our x-axis. if you can see that. That's kind of weird. So even though the y-axis, x of t, it represents the y, or the x. Anyway, makes it a little confusing, but the position of the particle, we're saying what is the position of the particle when it is farthest to the left? That means we need to solve for some t value that makes it the farthest to the left. And what I realized was, in this case, because of the picture, farthest to the left actually means down. They're asking where the absolute minimum is. And we find absolute minimums and maximums by finding derivatives. So what I did is I took the original function and I took the derivative of it, which I already know is v of t, right? So, except I'm not going to call it v of t because we're not really talking velocity. I mean, we could be. Anyway, but we're talking first derivative because that's where we find maxes and mins. So that was my velocity function, even though we're not using it in that context right now. And I knew that my two values there were 2/3 and 4, right? We've already done this math. I know that I had a plus here, and a minus here, and a plus here. The funny thing about this is I just realized that I actually solved this problem twice, and I did that number line twice. I took the time to do that each time. That's pretty funny. So I have all that written down, and then what I realized was that this right here is a maximum, goes up, comes down, that's a max. This right here is a minimum. So what is the position of the particle when it is the furthest to the left? I just solved for t. T equals 4. That is when it is the furthest to the left, or in this case, down, because our x-axis is really on the vertical axis. So now if I want to know what the position is, I just have to plug that 4 in, and I'm plugging it into the original equation because I'm looking for a point on the original equation. So x of 4 is going to be 4 to the third minus 7 times 4 squared plus 8 times 4 plus 5, and a calculator may not be used. So that means you have to do your math by hand. So 4 to the third I could not remember, so I did 16 times 4. So this is 24. 4 times 1 is 4 plus 2 is 64. This is 7 times 16, so 16 and 7. 6 times 7 is 42, that's 11. 8 times 4 is 32, and 5. So that gave me 64 minus 112 plus 32 plus 5. And I went ahead and I put all my positive numbers together. So I had 64 and 37. So I had 101 minus 112. I was like, oh crap, how far apart are those? They're 11 apart, so it's negative 11. It's a lot of math to do by hand. Sorry, my dad just texted me. Apparently my mom got me a cool birthday card. That's a good time. All right, problem 14. You guys, the end is in sight. We are almost there. Put this in my binder. All right, number 14. Based on the graph of the second derivative, how many points of inflection exist? So if you guys remember what the graph of the second derivative is representing, anytime it is underneath the x-axis, that means that the original graph was concave down. Anytime it's above the x-axis, the original graph was concave up. All right? So that means the points of inflection are when it switches from concave down to concave up. So here it switches from concave down to concave up, that's a point of inflection. Here it switches from concave up to concave down, that's a point of inflection. Right? So it's definitely 2. The reason this question is tricky is because some people think of points of inflections as found at x-intercepts of the second derivative, which is true, these are x-intercepts, but you actually have 2 x-intercepts right here, where the graph was concave down and stays concave down. And so that might be something, I'm not for sure about this exactly, but that might be something where you had some asymptotes in there and it's concave down and concave down and concave down. So whatever's happening here, this might be where a derivative was undefined or something. So that might not necessarily be the picture, but that's kind of the idea. It's staying concave down in all those places. Right. So 14 is done. 15. A rectangle is drawn in the first quadrant so that it has two adjacent sides on the coordinate axes and one vertex on the curve of negative ln x. So to start with, I did not remember what negative ln x looked like. So what I did is I was thinking e to the x would look something like this. So negative e to the x looks something like that. And I know that ln x is what happens when you reflect the graph. Maybe I should. Hold on, I'm going to do it like this first. Not negative. I'm going to be honest, I cheated and I graphed this on my calculator, but I'm trying to talk you through it. So this is e to the x. E to the x and ln x are inverses of each other. So if you want to know what an inverse is, it reflects over the line y equals x. So that's the inverse right there. Now that's positive ln x. So that means that negative ln x is reflected over the x-axis, and it looks something like this. So that's how you could have thought through the problem if you didn't know what that looked like. Anyway, hopefully that won't be an issue for you. Okay, so now it says find the x-coordinate of the vertex, and they're saying vertex not as in like parabolas, but vertex as in like corner. Find the x-coordinate of the vertex for which the area of the rectangle is a maximum. So they're building a rectangle using the two axes and where the two axes run into that curve. So they're saying if we can maximize this area, maximize the x times y, right? Because the area of the rectangle is just x times y. We want to maximize that, and then the xy is a point that's on that curve. So we're going to say our area is x times our y is negative ln x. And if we want to maximize or minimize something, we always take the derivative. So my area is negative x ln x, and I'm going to go ahead and take the derivative of this. So I've got the first times the derivative of the second, plus the second times the derivative of the first. And then it says, oh, and then we have to set it equal to 0 to solve that, right? Because that's where our maximums and minimums are. So this gives me negative 1, right? Because negative x divided by x, the x's cancel. And then that's minus ln x. So this equals 0. So I'm going to go ahead and add the ln x to the other side. So negative 1 equals ln x. And then to get rid of the ln so that the x is all alone, I just need to do e for both sides. So x equals e to the negative 1, which is the same as 1 over e to the positive 1. So 1 over e is our solution there. All right, our free response question, and then we're all done. I did not like the format of the original function. I didn't like it being written like that, so I went ahead and multiplied everything out. So I said 2 times x minus 2 is negative 2x minus 4. And then x minus 1 times x minus 1. I've multiplied enough to know it's x squared minus 2x plus 1. You can go ahead and FOIL that if you need to. When I multiply stuff like this, I don't like to FOIL it. I actually use a box. So I'm going to go ahead and multiply these out. Now the danger with this is if you make a mistake here, you're going to ruin the rest of your problem. So you got to be really, really careful not to make mistakes. Double check your work, triple check your work. Negative 2x times x squared is negative 2x to the third. Negative 2x times negative 2x is 4x squared. Negative 2x times 1 is negative 2x. Negative 4 times x squared is negative 4x squared. 8x, negative 4. So that means my original function is negative 2x to the third plus 6x minus 4. All right. Now it says we're using the interval, and actually there's a picture of the function there, which is real nice. So even though it's calculator inactive, they gave you something there. And so now we can go ahead and do the parts. It says determine the coordinates of the relative extrema. So max and min, we get that from the first derivative. We can actually already see what those are, right? You can see it in the picture. I don't think that it's valid for you to say, I can see it in the picture, that's what it is right there. Because even though it looks like the extrema are at 1 and -1, it's possible that they could be at some decimals and we need to find things more exactly and whatever. So also this is a calculus exam. I'm guessing that the 2 points they're going to give us for this part are like finding the first derivative and solving for it and finding the coordinates, right? So even though you can see it in the picture, I'd say it's still good to do it by hand. So I'm going to do part A over here. So my first derivative is -6x squared plus 6. And then I need to factor that and set it equal to 0. So take out the -6, that gives me x squared minus 1. So I factor that difference of squares, x plus 1, x minus 1, and it looks like where we predicted is exactly where the max and min are. So you can cheat and do this based off the graph if you want. I went ahead and took numbers and plugged them in. So if I plugged in -2, I had a negative times a negative times a negative, which is still negative. If I plug in 0, then I get negative for that, positive for that, negative for that, so that's positive. If I plug in 2, I get negative, positive, positive, which is negative. So for here, I'm writing it goes from decreasing to increasing at -1, increasing to decreasing at +1, and then I'm going to show my work. So I've got f of -1, no calculator here, so I got to do this by hand. So I've got -2 times -1 to the third plus 6 times -1 minus 4. So that is -2 times -1 is +2 minus 6 minus 4. That's -8. So -1, -8 is my relative increasing min. Should have looked at the picture, folks. All right, and then the other one, and that fits, right? -1, -8, makes sense. The other one is +1, so f of +1 is -2 times 1 to the third plus 6 times 1 minus 4. So that's -2 plus 6 minus 4. That's just 0. So 1, 0 is relative max. Okay, so I think that's pretty complete for part A. Part B. Let g of x be defined as the absolute value of f of x. Now, I don't know if anyone else panicked when they read that, but I did. And then I remembered that that g of x, f of x, when you're talking about the function, you're talking about the y coordinate. So your x coordinates be the same. You're still plugging the same x coordinates in for f of x. But when you spit out your result, anything that was negative in the original function is now going to be positive. So that made me realize that this point that's down here is actually going to be up here. And this point is going to stay there. This point is going to be over here. And I kind of used it to just draw this graph. I was like, oh, it's going to be like this nice symmetry here. Right, because it's just going to stay positive. And then I had 340 up here. And I did this right here. I was like, okay, let me follow this. So this right here, this is my g of x. All right, and so now I can answer the question. So it said, let g of x be defined that way. Determine the coordinates of the relative maxima of g of x in the open interval. Explain your reasoning. So here I was like, okay, my relative min becomes my relative max. So I was like, all right, -1, +8 becomes a relative max. And actually 1, 0 becomes a relative min, although they don't ask about that. The reason for this is you're still seeing horizontal tangents here, right? That's still a horizontal tangent line. But the increasing and the decreasing intervals have changed now that your y values have changed. So, so I wrote they still have horizontal tangents, so they're still extrema. And then I went ahead and I kind of drew this. Oh gosh, you couldn't even see that. So sorry. So it still has a horizontal tangent, so there's still extrema there, but the increasing and decreasing intervals switched. I'm so sorry you had to just stare at me and watch me write that. Not be able to see it. Go look up and see the points for these. So for part A, there were 3 points given. 1 point was given for finding the derivative. 1 point was given for knowing that x is plus or minus 1. And then 1 answer was given, sorry, 1 point was given for the final answer and your reason for that. And I think, I don't know that you had to explain the reasoning in words. This is where my unfamiliarity with the AP exam is going to hurt you guys. Because they didn't say like write a sentence about it, or they didn't say the word explain. But I do have some math there that kind of shows like where my answers came from. So I was thinking I probably would have gotten all the points on that. And then part B, 1 point is for your reasoning, 1 point is for getting the actual point. So I don't know if that reasoning is good enough. Actually, yeah, it looks pretty good when I compare it to what they had written. They said, the relative maximum will occur at the point -1, 8. All values of the new function are made positive with the application of the absolute value, and the relative minimum becomes a relative max. So we did a better job explaining than that. All right, now we got to move on to part C. So C says, for what value of x is the derivative of g prime not defined? So here we have to remember where derivatives are not defined, and that is at sharp corners, discontinuities, and vertical tangents. So if I look, I'm going to cover this up. If I look at that graph right there, I'm looking for vertical tangents, discontinuities, and sharp corners. And if you can see right here at -2, we got a sharp corner right there. So I said g prime of x is not defined at x equals -2 because there's a sharp corner there. Now you have to remember like why those different things are not defined for derivatives. For example, a vertical tangent is where something is where you can't find the derivative, and that's because the derivative is undefined. Like literally you'd be dividing by 0 and you can't do that. So that's why you can't take the derivative there. If you guys remember the discontinuities, you can't take the derivative because limits. Limits being there is part of the definition of a continuity. And so if you don't have a number you can evaluate, things like that, derivatives can't happen. So sharp corners, if you guys recall, the reason a corner is not differentiable is because the left-hand limit and the right-hand limit don't agree with each other. So here you have to include that. You have to say the limit as x goes to, this is a terrible place to be writing this. Limit as x goes to -2 from the left of g of x does not equal the limit as x goes to -2 from the right of g of x. And in this problem, they included that in their description of the problem, that the left-hand limit and the right-hand limit did not agree. They did say a sharp turn, sharp corner, so 2 points for that, 1 for knowing it was at -2, 1 for giving your explanation. All right, and then part D. So part D says find all the values for which g of x is concave down. Explain your reasoning. So I went ahead, part D said that my first derivative of the original function was -6x squared plus 6. I said that my second derivative was -12x, and so I knew that there was a point of inflection at 0, right? -12x equals 0, that's my point of inflection, 0. And then when I plugged values in, if you plug a negative number in here, that's positive. If you plug a positive number in there, that's negative. So for the original function f of x was concave up from -infinity to 0, and it was concave down from 0 to infinity. So I knew that g of x would be the opposite of that, because our y values are all being forced to be positive. So if you can see here, this is your little point of inflection right there. So I looked and I said negative, positive, like this. So when I was looking at that, I could see that that fit partially, right? Because if you ignore this right here, I can see that from -infinity to 0, well, not -infinity, from something to 0, I can see that we are concave down, right? This is concave down. And then from 0 to infinity, I can see that we are concave up. But then something about this is a part of the graph that gets a little weird, right? The -2 kind of ruins it, right? You can see that g of x is concave down right there, and then things get real strange at that sharp corner. So I said that it was concave down from -2 to 0, because you can see right here, this area right here is definitely concave down. This part right here at that sharp corner, it kind of gets weird. It looks like it's concave up again. So the concave down part we can definitely say is from -2 to 0. And I wrote just a sentence on that. I said that I know that it's concave down. For this reason, I also know it's concave down up until it has that sharp corner. And one of the things that we know about concavity is that it's concave down when the tangent line is above the curve, and I could see that all these tangent lines would be above the curve, but over here on this side the tangent line would be below the curve. So I kind of explained it that way. You get 2 points for this, 1 for finding the second derivative of f of x, and then the other one is your interval and the reason that you gave. And here you can, what I did is I was kind of verbally walking myself through all these things, and they did like a little chart. So whichever way you want to do it is totally fine.